Vitamin E, long recognized for its antioxidant capabilities and role in skin, cardiovascular, and immune health, is now being explored for its potential benefits in supporting bone health, a function that is gaining increasing scientific interest. While calcium and vitamin D have traditionally dominated the conversation around bone maintenance and strength, vitamin E is emerging as a valuable nutrient that may contribute to preserving bone density and protecting against the development of osteoporosis, particularly through its ability to reduce chronic inflammation and oxidative stress, two often overlooked contributors to bone degeneration. Osteoporosis is a progressive condition marked by the weakening of bones, often leading to fractures, especially in the hips, spine, and wrists. It tends to be more common with aging, particularly among postmenopausal women, but it can also affect men and younger individuals due to poor diet, lack of exercise, smoking, or chronic inflammatory conditions. One of the underlying causes of bone loss in these situations is the overactivity of osteoclasts, the cells responsible for breaking down bone tissue. These cells are stimulated not only by hormonal changes, but also by inflammatory markers and oxidative stress. This is where vitamin E may offer a valuable form of nutritional intervention. Vitamin E exists in several forms, including tocopherols and tocotrienols, both of which have demonstrated anti-inflammatory and antioxidant effects. These properties are particularly relevant to bone health because oxidative stress can activate signaling pathways that stimulate bone resorption, the process by which bone is broken down and minerals like calcium are released into the bloodstream. When this process outpaces bone formation by osteoblasts, bone density declines over time. By neutralizing free radicals and reducing inflammatory mediators such as cytokines, vitamin E helps slow this destructive cycle, creating a more favorable environment for bone maintenance. Some experimental studies, especially those involving tocotrienols, a subgroup of vitamin E compounds, have shown promising results in animal models. These studies suggest that tocotrienols may reduce bone loss in conditions that mimic postmenopausal osteoporosis. They appear to work by decreasing the expression of genes involved in inflammation while enhancing the activity of antioxidant enzymes that protect bone cells from damage. While more research is needed to confirm these effects in human populations, the potential is encouraging, particularly given the growing recognition that chronic inflammation plays a pivotal role in age-related bone decline. Vitamin E's indirect contributions to bone health should also be noted. By supporting the immune system and improving cardiovascular health, vitamin E contributes to better overall circulation and tissue repair, both of which are crucial for the transport of nutrients to bone tissue and the maintenance of a healthy skeletal structure. Additionally, because vitamin E may help reduce cortisol levels and buffer the body against chronic stress, it could mitigate one of the less obvious contributors to bone loss: elevated stress hormones. High cortisol levels, particularly when sustained over time, have been shown to interfere with bone formation and accelerate resorption, weakening bones from within. By helping to keep cortisol in check, vitamin E adds yet another layer of protection to the skeletal system. Furthermore, vitamin E supports muscle health and reduces inflammation in joints and surrounding tissues, which can be particularly beneficial for people at risk of fractures or falls due to osteoporosis. Stronger muscles, better joint function, and reduced inflammation all contribute to greater physical stability and mobility, factors that are just as important as bone density in preventing injury and maintaining independence with age. Dietary sources of vitamin E, such as almonds, hazelnuts, sunflower seeds, spinach, and plant-based oils, offer a safe and effective way to incorporate this nutrient into a bone-supportive diet. These foods are not only rich in vitamin E but also contain other nutrients that work synergistically to support bone health, including magnesium, healthy fats, and polyphenol. Incorporating a wide variety of these whole foods on a regular basis may contribute to improved bone strength and resilience over time. As with any nutrient, balance is key. While vitamin E holds promise in reducing bone loss and supporting skeletal health, it should be part of a comprehensive approach that includes adequate intake of calcium and vitamin D, regular weight-bearing exercise, and attention to lifestyle factors such as smoking cessation, stress management, and limiting alcohol consumption. Together, These efforts create the kind of internal environment in which bones can stay strong, flexible, and resistant to age-related decline. Ultimately, vitamin E adds depth to our understanding of bone health, not just as a protector against oxidative stress, but as an active contributor to cellular balance, inflammation reduction, and long-term skeletal integrity. As research continues to evolve, its role in preventing osteoporosis and supporting healthy aging may become increasingly recognized, adding another compelling reason to ensure it has a consistent place in our daily nutritional intake.